Okay, the final type of reaction that Module 7 asks you to learn and be able to write on your own is what they call complete combustion reaction. Please make sure to read about the other types of combustion reactions, the incomplete, and what they call a combustion of metals. Those are probably information that may show up on the test, but this is the one that you actually have to be able to write. So this is what I'm going to focus on in the video. So a complete combustion reaction is a reaction in which oxygen is added to a compound, and that compound contains carbon and hydrogen, and then it always produces CO2 and H2O. So this is basically something burned in oxygen makes CO2 and H2O. This is pretty easy because it follows the exact same template every time. You just have to fill in whatever compound they give you in the question. Okay, so if they say write, and then of course you must balance based on your compound. But this part of the reaction, plus O2 makes CO2 plus H2O, stays the same in every single complete combustion reaction that you will do. Okay, so this one's pretty easy to recognize, like in a multiple choice question, because this always stays the same. Okay, so they're going to give you a compound. Basically, you're just going to plug that compound right here into this template, and then you're going to balance. So it's pretty simple. So please don't worry when you realize they're only giving you one compound and you're like, where's the rest of the equation? Remember, if it says complete combustion, they're assuming that you know that means plus O2 makes CO2 plus H2O. So we'll look at a couple examples. So for instance, if the question said, write the complete combustion of C4H10, which is butane, all I'm going to do is I'm going to plug in C4H10 to my template. So I'm going to have C4H10 plus O2, so that's like burning in oxygen, makes CO2 plus H2O. So all I do is I take my compound and I stick it right here in this blank in the template. And then the rest of this stays the same. As long as it calls for a complete combustion reaction, this entire part of the equation will stay the same every time. Okay, now, then balance. So now I need to balance based on my compound. So again, I would save O to last because O appears 1, 2, 3 times, making it the hardest. So in these reactions, I would always balance C first, then H, and then O. Okay, so I'm going to start with C. So 4 C's, 1 C, so I'm going to put 4. Okay, now I'm going to do H's. I have 10 H's here. Over here I only have 2, so I need to put a 5, because 5 times 2 is 10. Now we're going to do our oxygens. On this side I have 2 oxygens. Remember, oxygen appears 2 times on this side, so I need to take into account both. Right here I have 4 times 2, which is 8 oxygens. You can write that down if it kind of helps you. Then right here I have 5 times 1, which is 5. So total I have, hopefully you realize, 13. 8 plus 5 is 13 oxygens. So now I need to ask myself, is there a number I can put here, multiply it by 2, and get 13? And it can't be a fraction. Okay, so hopefully you realize that's not possible. I can't multiply something by 2 and come out with an odd number like 13. So remember, back when I taught you how to balance reactions, what you can do is double everything you have written down and go back, and it should work out. So instead of having this 4, I'm going to make that 4 an 8. Instead of having this 5, I'm going to make that 5 a 10. Because I'm basically doubling everything I have written down at this point. Now I'm going to start over with my balancing and see if it doesn't work out. Okay, so now I have 4 C's and 8 C's. So I need to put a 2 here, because 2 times 4 is 8. Now let's do hydrogens. I have 2 times 10 is 20. 10 times 2 is 20, so I'm good. Now we're going to do oxygens. Okay, on this side, I no longer have 8. I have 16. 8 times 2 is 16. 10 times 1 is 10. 16 plus 10 is 26. So I have a total of 26. Can I make something times 2 equal to 26? Yes, I can. That answer is 13. So I know that was a lot of balancing, and those are some pretty big numbers, but that is the correct answer for the complete combustion of butane. 2 butanes plus 13 oxygens make 8 CO2 plus 10 H2O. Okay, let's go to our second example. So C6H12O6, and the directions would say something like, write the complete combustion for this compound. So in this case, it's C6H12O6. And again, all I'm going to do is plug it into my template for complete combustion. So C6H12O6, and then plus O2 makes CO2 plus H2O every single time. It makes these pretty easy to recognize. Okay, now I'm going to balance. So I've got 6 C's here. So I'm going to put a 6 there. I've got 12 H's right here. So I've got 2 over here. So 6 times 2 is 12. Now let's look at our oxygens. Please be aware. Oxygen appears 1, 2, 3, 4 times. Okay, so you need to take into account all of those. This is probably one of the more difficult ones in terms of balancing because you have a lot of oxygens to take into account. So on this side, don't just think you have 2. You also have 6. So that's a total of 8. You can make some little notes if it helps you. Over here I have 6 times 2, which is 12, plus 6, which is 18. Okay, so I need to make this over here equal to 18, but realize I have 2 ways to do that. I can put numbers here to change this oxygen and number here to change this oxygen. Okay, so here's my thought process. If I put a number here, it will change my C and my H. So, if at all possible, I want to try to balance this just by changing this one oxygen here. So remember, I already have 6 right here. 2 is 8. I need 18 total. Well, if I decide to leave this 6 as it is, then I really just need this to add up to 12 because 12 plus 6 would give me a total of 18. So if I put a 6 here, 6 times 2 is 12 plus 6 is now 18. So I should be balanced. Let's check it out. 6 C's, we're good. 12 H's, 6 times 2 is 12. Now watch, I have 6 times, that's a 6, sorry, it's hard to read. 6 times 2 is 12, plus 6 is 18 total. Let's see how my total on this side goes. 6 times 2 is 12, plus 6 is 18, so I am balanced. That is my complete combustion. So just take your time, think through the process. The steps will work. You just need to make sure you take into account all the different aspects. And when you're thinking about complete combustion, remember you have this template. Whatever compound is given in the problem plus O2 yields CO2 plus H2O every single time. And then basically your job is to balance. These can be the hardest ones to balance because of the O's appearing at least 3, sometimes 4 times. So just make sure to take your time. Don't get frustrated. And if you get kind of stuck, remember you can always double everything and come back and it should work out. Okay, the final 3 videos in this module will cover the math that is associated with chemical reactions.